I know what you're thinking. You've heard of the Git Virtual File System that enables large dev teams with big code bases to be able to use Git without all the slowdowns from the mechanics inside Git, just like the Windows team inside Microsoft. But wouldn't it be cool to see the PM of this product demo it so we understood how it actually impacted your developer workflow? Well, you're in luck. That's this episode of Dev Radio. And welcome to the next episode of Microsoft Dev Radio. I'm Jerry, and this is part 2. We're talking about the Git Virtual File System. Inside Microsoft, we have a lot of software developers, a lot of teams, and a lot of code. We love Git just like you love Git, but we had a lot of trouble enabling it because we had so much content. So along comes the Visual Studio Team Services team, coupling with the file system team there in Windows, coming up with a solution to solve this problem. We had him on the last show, Christian Allred. Christian, welcome back to the show. You're on the file system team. Welcome back.
Thanks, Jerry.
Yeah. Oh, I'm glad you're back because this is pretty exciting stuff. And we've got Saeed Noursalehi. Saeed, you're a program manager over in VSTS. Welcome back to the show as well.
Glad to be here.
Now, both of you guys are here really to show us a little bit. We talked about the problem and kind of the nightmare solution that we had. And then all of a sudden, you guys came up with a really great idea. Remind us real quick, Saeed, what are we talking about?
So really we're talking about taking Git, which works great on repos of like a few hundred or a few thousand files, and in teams with a few dozen people, maybe a few dozen branches, and trying to take all of those dimensions and scaling them up by a couple orders of magnitude. So the Windows repo has 3.5 million files in it, 3,000 plus developers, more than 100,000 branches. And each of those dimensions of scale cause problems for Git, and so we've been able to solve all of them.
And remind us. So we've got these millions of files. How do they translate into time? Because time is really the problem.
Right. Well, if you just did a normal Git clone of the Windows repo, doing real basic operations like a Git checkout takes something like 3 hours. A Git status takes about 10 minutes. A Git add and commit takes you about 30 minutes. And these are operations, especially status and commit. These are things that you're doing, many, many times throughout the day. You don't want to be waiting like 10 seconds, let alone 30 minutes.
That's right. Absolutely. And people like Christian, software engineers, they are intolerant of just that kind of wait. Time is really the problem. Christian, first of all, terrific shirt that you've got on today. Some say time is the fire in which we burn. Do you know that quote from this?
Yes, I do. Star Trek Generations.
Yeah, so what do you think? Here you are, you're trying to check out, and it takes 3 hours. What? That motivates you, I suppose.
Oh, yeah. Especially for me, like I have a tendency to forget what I was doing if a command takes too long to return. It's like Douglas Adams said in The Long Dark Tea Time of the Soul, mentioning the British telephone system, that infuriating pause that the British telephone system has between dialing a person and it starting to ring that enables you to forget who you're calling. That happens to me all the time. If I put in a command and it's waiting and waiting, I think I'm going to go off and do this other thing, and then I totally forget.
Yeah, I get it. And, it's not like we don't have a lot of software engineers working at Microsoft. When you count up what everybody's worth for the hour and then multiply those by the people and then by the hour, it's worth building a solution like this. Absolutely. Now, Saeed, talk to me a little bit about Git on the whole. I suppose it's possible that we have a couple of developers watching the show today who maybe aren't familiar with the inner mechanics of Git and what might cause some of these problems.
Sure. Let's talk about some of the inner data structures that Git uses to track its files and its history and why those cause a problem. And I've got some slides that I can show you to kind of walk through these concepts.
Okay, Saeed, I can see your screen.
Okay, so I just want to talk for a couple minutes about the data structures that Git uses so that we can have these concepts as we're talking about the scale problems later. So to track your history, Git has this concept of a commit. And every time you submit a change, you run the git commit command, you create a new commit object. Each commit really represents the state of all the files in your repo at that time. And then the commit object points at a tree object, which is a recursive data structure. A tree can point to other trees, and it can also point to blobs. And a tree is kind of like a folder, and the blobs are kind of like a file. And I say kind of because they don't map exactly to the file system concepts, but they're very close. And so any commit object gives you a snapshot of all of your files in the repo at that moment in time. And it's kind of like the core data structure in Git. So if you look at any kind of a historical tool, if you look at like your history in GitK or in the VSTS website, you'll see a graph of commits, and any commit always has one parent if it's just a linear, if it was a commit added on to another commit, or it can have two parents if it was a merge, and then your branches are pointers to those commits. Mm-hmm. These are just some of the basics here. And if you look at internally, like within the commit object, this is sort of how it'll look. If you have, say you have in your repo a folder named A, and it's got a file in it and a file at the root, you can see the folders in the files on the left sort of map to the tree and blob objects on the right. Okay, just to give you a pictorial view there.
Yeah, makes sense to me.
And these are some of the real basic Git commands that everyone uses. You do a clone, and what happens with a normal Git clone is you copy the entire history of that repo, all the commits that make up the whole history of that repo, including all of the trees and blobs, and basically all the contents of that repo. You download them all at clone time. For most repos,
I'm not just getting the source code, I'm also getting all the historical commits. It's pretty significant.
That's right. I mean, for most repos, that's totally fine. For a large repo, you can imagine that takes a long time. And for the Windows repo, where we're talking about 350 gigs of content just at the latest commit, and then you have multiples of that throughout all the history, it just takes too long.
Yeah.
And then when you run a git checkout, so what git checkout does is it takes one of those commit objects and it scans through all of the trees and all the blobs referenced by that commit, and for each tree that it finds, it lays down a folder on your disk, and for each blob that it finds, it lays down a file on your disk. Okay. And so you end up with a complete snapshot, a complete copy of the code in your working directory. And again, 3.5 million files, that takes a long time to go and create all those folders and files.
Yeah.
And so, just keep on going down the list. The theme will be the same. You run git status, and it has to go and check every file in the working directory. And what it does is it compares the file in your working directory with the file that was in the commit. Technically, it compares it with what was in the index, which is a cache of what was in the commit. And it tells you, well, here's the files that are different between the two. And commit, when you're ready to submit your changes, you run git commit, and it does a similar kind of check to see which files were different, and then constructs a new set of trees and blobs and a new commit object to add to the graph.
But of just the deltas, commits only the deltas that you made, right?
It doesn't really store deltas. It stores new blob objects. And then, yeah, we can get into those details if you like. But logically speaking, each commit is a complete snapshot. It's not a delta.
Okay.
Under the covers, the storage does get deltafied to save on some space.
Okay.
But the point being, like, all these commands are linear on the number of files, which is the source of the scale problems. I also want to show you in a normal Git repo how these things look on disk. So what I've done is I've cloned our VSTS repo already, and I've cloned it twice. I've cloned it once with normal Git and once with GVFS. Okay. And right now I want to show you the Git version. So I'll just open up Explorer here, and the size of it. And as that's counting, I'm going to go into the .git folder, and you'll see, like, I just cloned this thing, so it's totally clean. And I'll go. So when you clone a repo, Git always creates a .git folder, and inside the .git folder is all the metadata of the repo. And in the objects folder inside of there is where it stores all the objects that it has downloaded. And in the pack folder here, you'll see there's this 8 gigabyte pack file that I had to download. and that contains all of the history of the VSCS repo.
Ah.
And you'll see next to it over here, the size of my full clone is about 11 gigs. The 3 gigs is the size of my working directory.
Yeah.
So the 8 gigs is the whole history all compressed, and then what it opened up into the working directory is about another 3 gigabytes there. And so this pack file here contains every commit, tree, and blob. And when I run commands like checkout or status or any of those things, Git will be able to find those objects in here. And if we go back up to the source folder, like these are all the folders that it checked out, all the files that were in there. You know, there's I think at the last count there was like 120,000 files, something like that.
Okay.
So that's the basic structure of it. I'll also show you inside the .git folder. There's a couple of interesting files here. The head tells me what what branch I'm currently at. The index is a data structure that caches the state of every file in the repo, and that's important because I said, anytime you say every file, you have to remember in the Windows repo that's going to hurt. And so
because you've got a pretty small, 3 gig is all it is, and that's already at 9. Yeah, I see it.
Exactly. Okay. So with 100-some thousand files, this thing is 19 megs already. Right. In the Windows repo, it ends up being, I think, like 250 megs for the index. And more importantly, there's 3.5 million entries in there. And so any operation that we do that manipulate the index ends up being linear. And so our whole challenge here has been to take these operations that are linear on the number of files and break that linearity. And instead, we've tried to make it so that they become linear on the set of files that you care about, not the set of files that exist in the repo.
Okay. So. All right, so we have 19 megabytes there, 11 gigabytes in the overall folder, 3 gigabytes in the working folder. How does this folder structure compare to the GVFS folder?
Great. So let's go take a look at that. So what I've done here with GVFS, it's a virtual file system, and it has a concept of being mounted and unmounted. And right now I've got it in an unmounted state so that you can see it as I've cloned it, and you can see exactly what's on disk. And so let's take a look at what that structure looks like. And you'll see when we go into this one, we've got a .gvfs folder to store some of our own metadata. We don't really need to go into that too much, but the source folder looks very empty. You can see there's nothing here on disk right now, except there is a .git folder. And the .git folder is all the same structure as the normal Git clone. Everything in here is a normal Git repo. Okay. Except you look in the objects folder now, and you see that
it's empty.
It's empty. And actually, we're playing some tricks here because what we've done is Git has this concept of alternates where you can string together multiple locations of these objects. And in fact, what we're doing, so if I open this file, you'll see that it's pointing at this other path. And so I'll go to that other path and show you. In the .gvfs folder, this is where we're actually storing our pack objects. And you see we have like about 1 gigabyte worth of data here. So instead of downloading the 8 gigs, we downloaded 1 gig. And the reason for that is what we've downloaded here is remember before we said that the commits point at trees and blobs. Now, commit objects are pretty small. They have like a message in them, some timestamps, the name of the author. Trees are pretty small. They have like a name and then pointers to, and by pointer I mean the content ID of all the blobs they point to. So the commits and the trees are all pretty small. It's the blobs that are really big. And so what we do is initially when we do a GVFS clone, we download all the commits and trees and we leave all the blobs behind. And so that's where the 1 gig here came from.
So a 1 gigabyte file, that's pretty significantly different than an 8 gigabyte file.
Right, and in fact, in the Windows repo, the difference is even bigger because it's the Windows code base is really, really large. So much of that is the contents of the files, and so the initial pack file for the Windows repo is 100 gigabytes plus, whereas what we end up prefetching in GVFS is a couple of gigabytes, and so the difference there is very significant. Yeah. And then what we do is, we've downloaded the commits and trees, and then we go and we download the blobs on demand. So let me show you right now the working directory, as we saw before, is all empty.
Yep.
And that's because the repo is not mounted. And so that's what I'll do next is I'll go into my GVFS clone here on the command line, and I'll tell GVFS to mount. And what GVFS mount does is it attaches the gvfilt driver to this volume, and Christian will talk about all the details of how that works under the covers. And gvfilt is able to then intercept enumeration requests and file open requests, and it sends those requests up to the GVFS process in user mode. And GVFS says, well, you're trying to enumerate this folder, and here's what Git thinks should be there, so we'll make it appear. And so you see now all these folders are here. And if I go to Explorer and I refresh that, all those folders are there. And all that happened here is, as we enumerated, GVFilt intercepted that. GVFS got the request. We looked at the Git data structures, and we made these folders appear as you access them.
Mm-hmm.
And so now
all those folders have appeared, but all those folders are currently empty.
That's right.
Okay.
And let's prove that. I'll unmount, and you'll see. And through a quirk of how Explorer works, these folders got laid down because Explorer did some I/O on them. But if we go into any of them, so like I'll go into here. You see
and you unmounted it because you didn't want to invoke GVFS to go pull all those files down when you start navigating into it.
By unmounting, what I'm doing is I'm showing you exactly what's on disk, and all the virtual projection is gone right now.
And so this kind of a pause. Almost.
That's right. And you'll see like this list. Basically now in the source folder we see all these folders that got laid down, but all of them are empty. Like there's nothing in any of them. So it's all virtual right now. Okay, so let's mount it again, and I'll show you as I walk around and do some things. What I'm going to do is I'm going to go and browse through a few folders. And so, for example, let's go into this TFS folder, and you see like everything just shows up. And there's a slight pause if you notice when I typed dir, and the second time there's not. And the pause is because these sizes that you see on these files are not actually stored in the Git metadata, so we had to ask the service, the VSTS service for the sizes there. But we cached them all locally.
Are those files also not actually filled at the time?
They're not actually there. Like right now, if I were to unmount and do a dir again, there's nothing here. So these are all purely virtual. There's literally nothing on disk, and we're just showing them to you as you enumerate. And so I'll just keep browsing, and nothing here. And I want to go into the. Let's see, there's a folder I wanted to go, here we go, source control, and anyway, I'll just open a file here, it doesn't really matter. So basically, I'm browsing around, and I'm going to open this file, and slight delay, and there's the contents. And
I see, so that delay is it's actually going and getting the contents. Now, Saeed, does this mean that I can't work offline?
Well, what it means is you can't access a file for the first time while you're offline.
I see.
But what we did is as soon as we opened that file, we created this file on your disk. I'm going to unmount again and show you.
Okay.
And you see that one file is sitting right there.
That's the only one, yeah.
That's right. And so that one file is there, and any file that you've accessed will be present. And so normally what happens, for a typical developer scenario workflow is you're going to run a build, right? You're not just going to go and open one file here, one file there. You're going to run a build. And as you run a build, it's going to download all the files that you cared about, and all those files will be present. And so you can work offline on those set of files if you want to. And
so that's the way, right? Because a build will make a call to all these different source files.
That's right. Because your build is going to read those files, so it can compile them, and so really that's the magic here is a typical Windows developer is not going to build all 3.5 million files. They're going to build maybe 10,000 or 20,000 or 100,000 files of those 3.5 million, and those are the only files they end up pulling down. Yeah. And so what I've shown you so far is one of the two things that GVFS does. GVFS helps you not download all the contents, and it only downloads the specific files that you need. But that's only half the battle. The harder part is actually that when you run a command like git status, you don't want it to go and scan all 3.5 million files.
Right.
So the way we've solved that problem is Git actually has this concept of a sparse checkout, which what that does is it in a normal Git repo, if you don't have GVFS, if you use the sparse checkout feature, you tell Git, like, there's these 100 folders in my repo, but I only care about this one folder, so only check out that one folder. And so what Git does is it keeps track of, this is the only folder I care about, pretend like the rest of them don't exist. So we're kind of extending that feature, and I'm going to show you here in the .git folder.
Okay.
There's this file called sparse checkout. And what we do is we tell Git, we're kind of lying to Git intentionally. We tell Git that the repo is empty. Like we're telling it there's this one file, and that's all that exists. And so now when I run a git status, Git is actually only going to look at that one file, even though there's 120, 100 something thousand files in this repo.
Yeah.
Well, that's the only file that Git will look at. And here's the really interesting bit. So I had already opened that one file. Which one was it? It was Git helpers. Yeah. And you notice it's still not in that folder, in that sparse checkout file, even though there's a file that's on my disk. But because I had never modified it, we still know that it's clean. So there's no point in telling Git to go look at that file. And
which, thank goodness you do it that way, because if I say build and it pulls down, just 100,000 files out of 100 million files, that's still gigantic.
Exactly. And in fact, our earlier designs of GVFS they had to add any file that you've ever read into the sparse checkout, and that was exactly the problem, is that the more you run bigger builds, the more your Git commands would slow down because they had to go scan through more files.
Yeah.
Now what we've done is we made it so that if I open this file again, we've made it so that only when you edit a file and make a change to it does it show up. And so I'm going to make some changes and just add some spaces and save it. Now if I go here, you see that the file changed.
This is my typical commit, by the way. A couple, maybe a correct the spelling on a comment.
Right. But you see that now, now the file shows
change. Oh yeah, that's beautiful. Yeah. Which, I mean, even if I went in and changed, 100 files because I'm working on a really large bug, that's pretty manageable.
Exactly. And so of those 3.5 million files, you might have hydrated maybe 100,000 of them, but you're only going to edit a couple dozen. And so now we've taken in this git status command that used to take 10 minutes, and now we can run that same status in less than 3 seconds. In the VSTS repo, it's even faster. But you see, like, it found that file and it knows that it's dirty. And so that's really the magic here, is that we're able to trick Git to only look at the files that we know could be modified.
What do you do with files that are not part of the build process but are more like assets, and I'm going to need them at runtime and they don't show up at build time? Is there a way for me to point to a handful of files or folders and say, I also bring down the assets folder, also bring down my, class diagram or something like that?
Yeah, well, there's nothing special about the build here, right? All that's happening is basically any tool that you use that accesses the file system is oblivious to the fact that underneath the file, like within the file system, GVFilt is intercepting those calls and allowing GVFS to hydrate the files as needed. And so it really doesn't matter if you're accessing those files at build time or at runtime, or if you're accessing it via a build or an IDE or whatever.
Oh, I see. So you're saying as soon as I actually run it and I need that asset file,
it'll show up. Yep.
Okay.
The first time you access it, there's going to be a delay as it's being downloaded, and then the second time.
And that delay could look like a runtime error, and maybe running it the second time, everything will be there when you need it. Okay,
right. And we have had some bugs around those things, and for the most part now, I mean, we have 3,000 devs using this every day, and they're pretty successful with it.
Yeah, that's the beauty of it, isn't it? That we kind of put it through the paces, and we do it in a serious way. Let me ask you a little bit more about it fundamentally here. As I use that, and there's a time lag, what happens if I, from time to time, people lose their network connectivity, Saeed, right. And like I do. And what happens when I need to get that file, but I just happen to be in that moment when my network connectivity is down?
Right. So what's going to happen there is, if you're accessing a file for the first time, excuse me, and your network is unavailable and we're unable to download that file, we fail that I/O attempt. And so what that does is, your tool will end up hitting an error, but we make sure that we preserve the correctness of the file system. Like that's the most important thing there. And we also have some tools in the works that'll monitor that sort of situation and give it'll tell you that this is what's happening. So you're not just seeing like notepad failed on me. But this is sort of the thing about intercepting the file system calls is if we fail, the file system fails. So that is definitely something to be aware of. What we do have also is GVFS has this ability to prefetch. And so, for example, if you know that you're going to be going offline and if you know that you want the contents of a particular folder, you can run a command and tell it just prefetch everything in that folder. And that way that folder will be available to you. And even if you don't have your network, you can still access it.
Now, how do I release a folder if I ran the wrong build, pulled down a couple of files I don't really want? Do I just unmount, delete them, and remount, or is there a better way?
No, you can't really. I mean, that's not really going to solve the problem for you because if you unmount, we actually don't allow you to then do any modifications to the file system because that could lead to corruption. Yeah. So we have there's a GVFS dehydrate verb that you can use to, like, if you just want to wipe the slate clean and kind of go back to a purely virtual state, you can do that.
Nice. Now, I guess when I first go get my files, repo without GVFS, it could take 30 minutes to 3 hours.
Right.
And now that first time, I mean, there is an actual time. You can't get away from the fact there's going to be a cost. We just make it so it's a much, much smaller cost, an incremental cost ongoing. So that initial time could still take, 15, 20, maybe even an hour worth of time, depending on how large the build and the requirements of files are. But it's trivial compared to the larger scope, and then the ongoing commits aren't so painful.
That's exactly right. I mean, basically what we're doing is trading upfront costs for incremental costs, as you said. And the reason that works so well for the Windows team is the fact that most developers only need a small subset of the files. And so paying that ongoing cost for the ongoing incremental cost for that small subset is a huge win.
Now, are there any gotchas that a developer has to kind of think in mind? Like, I'm a typical developer. I totally know Git. I'm going to install and mount the virtual file system here. Is there a change in my workflow?
There's one important change up front, which is instead of running the git clone command, you run the GVFS clone command. But after that, actually, we've done everything we can to not change your Git workflows. And so all the same Git commands work. We've had to block a couple of commands that don't really make sense. Like Git has a command, fsck, that'll try to validate all the objects in the repo. And in a virtualized repo, like, most of the objects are missing, so that command doesn't actually make sense. But it's not something that developers normally use on a regular basis. But for all the commands that you would use, like checkout, merge, rebase, status, add, commit, all those commands work exactly the same on a GVFS clone as they would on a normal Git clone. I
want to understand the environment that you're running. What is it that you have running to enable GVFS on your client side?
So when you install GVFS, what it does is it installs the GVFilt driver, which is a file system mini filter, and it installs the GVFS application. And those are the two pieces that you need, as well as you need to have Git for Windows installed on your machine too. And so you then, when you run, so you have GVFS on your machine, and you can run a GVFS clone, and GVFS clone attaches the driver at that path. And from then on, any I/O that happens in that path causes GVFilt to talk to GVFS, and then GVFS can talk to either Git locally, or it can call out to VSTS, or it can call out to a cache server to get the data that it needs, and then you're off and running.
Yeah, I have to tell you, I don't know a lot about file system mini filters. Is it a service that's running, or something lower level than that?
It's lower level than that. Christian has all the details on how the mini filter works, and I think he'll cover that in depth. But it's a driver that's running in your kernel, and And the nice thing about it is totally transparent to all of your tools. So none of the tools like Notepad or my compiler, none of them have any idea that this repo that we're using, that this file system that we're on is virtualized.
I love the fact that your demo had nothing to do with Visual Studio, just showing that this isn't any developer, any language, all in Windows. Is Windows obviously this is built for the Windows file system, and is it limited to Windows today?
For now, yes, it's on Windows. Actually, we've started on trying to build it for the Mac as well. We're very early stages there.
Cool.
But yeah, because
cool.
it uses because it requires a driver, it's very specific to Windows at the moment, and we're trying to figure out how to port it to other platforms.
Okay.
Yeah.
All right. Cool. I like it. I like it a lot. Now, Christian, you are on the Windows team. This is built for the Windows team? Is the Windows team actually using this?
Yes. We've onboarded the Windows team. As Saeed mentioned, there are about 3,000 developers in the Windows team, and we onboarded everybody in stages, and each stage went very well. In fact, our upper management was very happy with the way that the transition to Git went. And as of just a few weeks ago, the last Windows team was onboarded to Git, and now every developer in Windows uses Git every day for their development.
And the virtual file system that you and your team put together for making it possible is what enabled the whole thing.
That's correct.
Well, nice work. Now all right, so that's internally. Saeed, talk to me a little bit about this being ready for our customers.
Sure. The fact that the Windows team is up and running and has been working with GVFS for months now is a pretty good indication of the quality of the product. At the moment, for anyone outside the company, the GVFS code is all available on GitHub, and it's there for anyone who wants to preview it and try it out. We haven't yet fully released it, mostly because the GVFilt driver has been still under development, and we've been trying to figure out the correct way to ship the driver. But other than figuring out the vehicle for delivery, the code is in a great state, and if there are teams out there who have a need for GVFS, it would be a great time for them to try it out.
Just email you directly, just bgates@microsoft.com.
Actually, our repo up on GitHub would be a great place to ask questions there, and they're also welcome to reach out to us. Yeah.
You know what's cool about a project like this, where we're like, well, we're not totally ready for customers, but we see it coming. We are actually using it internally, and it turns out a third of our business is still Windows, and we wouldn't, spoil our bread and butter on something like anything that doesn't work, right? And so that's something that's, I'm sure, very appealing when some lead developer or architect who's listening to this, who's like, man, we have a lot of stinking files, and we've noticed that it's very slow to clone and very painful to commit and all these things as well. Maybe this is a solution for my team. I'm sure it's very exciting for them to see that there's hope, because otherwise, what are they going to do but all these weird workarounds where they have to manipulate their code in ways that you don't really want to do. You want to do it the way it feels right and proper. And so it's kind of cool that this is going to, what do you think we're going to call it? You think it's going to be externally called the GVFS? It's got to have, it's only 4 words. That seems like we need a lot more words in there.
I'm better at writing code than I am at naming things. I'm sorry.
I think that could be said with every single person at Microsoft. I'll bet it's going to be an awesome name, though. We'll have to, the box will have to fold out so you can read the whole thing. It's going to be great. Now, internally and structurally, I'm actually more curious a little bit about how the file system works functionally. Now, Christian, we saw these great demos by Saeed. I'd like to see a demo really from you to kind of walk us through. There are a lot of moving parts, and honestly, some of this is black magic that guys like you, for 18 years working on the file system team, obviously, you know this in your sleep. You dream about these weird APIs. I've never even heard of many of them. And earlier we were talking about how you recognize the code on Star Trek Discovery to be Windows code. I mean, it's just awesome. I would look at that and I would think they just made it up. Just put a monkey on a keyboard and just went crazy. But no, that was code that you guys have written, not a monkey.
Now you're repeating yourself.
Now I'm repeating myself. That's right. But Christian, would you be willing to show, maybe not on this call because we've gone a long time, maybe come back another episode and show us the fundamentals of GVFS behind the scenes?
Yeah, that'd be great.
All right, that'd be perfect. All right, if you're a developer, if you're an architect, if you are on a dev team at all and you have more than one file in your repo, then maybe this is something you need to start thinking about. Maybe you start realizing there are some slowdowns and there are some things that are painful in your repo and your workflow, and your dev team starting to complain. And isn't it cool that something like this is actually here, already built into Visual Studio Team Services and almost available prime time for everybody else? We're using it internally for Windows. It's pretty exciting. Wouldn't you like to know how it all works? We'll pull back the curtain, and Christian will show us all the magic next time. So join us next time. Saeed, thanks for being on the show today. Christian, thanks for being on the show. Guys, I look forward to talking to you again.
Thank you.
Thank you.